So section 2.2, we have the metric system. Here's our objectives. To become familiar with the metric system, its prefixes, and identify units of measurement, and become familiar with the symbols used to represent those units of measures. So, in the U.S., I don't know why, but we still use this customary system just out of tradition. The metric system is so much better because it's base 10. We're really one of the only major developed countries that still uses the U.S. customary system. But yeah, having base 10 is pretty nice as far as the math is concerned. So, here's some examples to convert, 3 miles to inches. Of course, we would multiply by 5280 feet per mile. Miles would cancel. And then we cancel our feet, right? There's 12 inches per foot, so our feet would cancel. And we'd end up with 190,080 inches. Whereas if you're just going from kilometers to centimeters, as long as you know there are 1,000 meters for every kilometer, and then there's 100 100 centimeters per meter. Now you're just multiplying 3 times 1,000 times 100, so you're going to have 5 zeros after the 3, which is really nice mathematically, right? So we have 3,000 centimeters. All right, let's talk about the prefixes with the metric system. So, tera, you got that capital T. It means 10 to the 12th, right? There's a factor that's being multiplied by kilo. For example, down here with the lowercase k is 1,000, 10 to the third, right? In other words, it takes 1,000 meters to make up 1 kilometer. And I should say our base, or our grams for weight, our meters for length are just regular. Okay, so this is, in other words, for a kilometer, right? It takes 1,000 meters to make up a kilometer. Centi is 1/100th, so in other words, it takes, for a centimeter, right? Centimeter, it takes 100 centimeters to make up a meter. So here's some table again as far as conversions between metric and U.S. customary. Okay. All right, let's do some problems here. So what's the symbol for a nanoampere? Go up here and you say, well, nano, if you notice right there is lowercase n, and ampere is capital A. I should say that ampere is capital A. So nanoampere. That'd be the symbol for that. How about megavolt? So we're going to go up here. We're going to look for mega. You see how we have a capital M right there? Mega, capital M. And volt, I should also say, is a capital V. So capital M for mega, V volt. So volt is capital V. So mega, capital M on that matrix prefix table. All right, so this one, rewrite the given quantity so that all numbers are between 1 and 10. Use the proper metric symbol for the given unit. So we have 0.000009 grams. In other words, if you were to read this, this is 9. And what position is that? Well, that one's tenths, hundredths, thousandths, 10,000ths, 100,000ths, millions. That's 9 millionths 9 millionths grams, right? Grams. 9 millionths of a gram. And so what we're going to do is we're going to use the prefixes to find the millionths position. So we're going to write this as 9, and then the prefix will go right there, and then G for grams, right? Grams is just a G. So let's go find the prefix for millionths. So we go up here and we're like, oh, that's the mu symbol right here. See the millionths position? That's right there, 10 to the 6th, right? 1 over a million. So the millionths position, so we'll put that as a micro. And by the way, this symbol is mu. That's the Greek letter mu there. But we say micro. Okay, so microgram. 9 micrograms. Let me erase this. So 9 micrograms. Any questions on that? All right, let's do similarly for this one. Oh, you know what? I was going to make that a 7, not an 11. Sorry about that. Well, if you notice, that's 7 billion position meters, right? 7 billion meters. 7 billion. So what we're trying to do is trying to write it as 7, a number between 1 and 10, and then the prefix for billion, and then meters is just lowercase m. So we just go up and we find our symbol for billion. And it looks like it's right here, billion, giga. So this is 7 gigameters. So capital G, see that capital G right there? So giga meters. 7 gigameters is the same as 7 million meters. 7 billion meters, sorry. All right, last one, and then we'll kind of get working the system. The sides of a rectangle are given in feet. So you have this rectangle, right? It's something feet, something feet. What is the symbol for the units of the area? Well, if you remember, area is length times width, right? So like, let's say this is 7 feet and this is 3 feet. So we'd have 7 feet times 3 feet if we're trying to find the area, or 21 square feet, right? Feet square. So it's just asking, what's the symbol for the units of area? You know, so square feet, right? If you have feet and feet, it's square feet on that. And all right, I think that's enough to get you started on this. See you next time.